I'll I'll start from the delete again. So why delete? In position c equal to 1, printf enter the position, because you need to take the position directly. Okay. You don't have to enter the data, any data here, because you know data is already there. You have to just delete it. You have to just delete it. So enter the position, scanf %d and %position. Now, if there is no node at all in your list, then you will check for the empty node, empty list. So if first equal to null, printf list as empty. Else if, what is the second condition? Else if position equal to 1 and first link equal to null. Then what does it mean? What does it mean? Printf, you can directly write that printf deleted element is %d. Okay. You can write little bit more decorated way if you want. H %d, and after that let's use /n as well, so that it will come next line, comma, first of data, okay. So now you have assumed it is deleted, but what is there? Still that node is there in the, that place was stored in the memory, no? Whether it is there in your list or not. So you can use one function, predefined function, free, FREE. You can write free first. Okay. And first equal to null. So that you will free that place. Now, this is noted down. What is? To remove that node from that memory location. Free the memory space. Free the memory space which you have already reserved for the first. Okay. Then next, what will be the condition? Yes, what happened? Now, if you have the position, if you have the position 1 which you want to delete, and there is next node as well. This one was what? If there was only one node, isn't it? If you have you want to delete something from position 1 and you have next node as well, means 2, 3 nodes are there. Okay? Then in that case, which condition you can check and how can you check? So you will write else if position equal to 1 and first link not equal to null, means you have next node as well. First of link not equal to null. First of link not equal to null. Then in that case, what will you write? Current equal to first. You will have to count now, no? You will have to go next node, next node, next node, and you will have to check the position which you want to delete. So current equal to first means you are right now in the current node, and first equal to, you have to go to next. So what will you do? First link, isn't it? First equal to first of link and current link equal to null. So actually this is whatever the node you wanted to delete it, that is becoming in the current. And new first is what? New first is what? New first is what? I will sorry, I will explain it. What is this? I will explain it with example, then hopefully you will understand. Suppose that currently these are the two nodes. So this is your first or not? Here you had semicolon. So this is your first. Now what you are doing, you want to delete this node. Position is 1, means this you want to delete, and first link not equal to null means first link you have some node. Now if you want to delete this node, so this is right now current as well. This current node you want to, that's why I wrote current equal to first. Current equal to first. Now if you want to delete this, and let's take one more node. If you want to delete it, so now new first will be what? Next one. So first equal to, this is the first, But new first you have to write this one. So how will you reach here? Here what is the address? First link, isn't it? So this new first will be equivalent to first link or not? That's what you're writing. First equal to first link. And now this was your current. So current link, what will you write? Null. Means this connection you have cutted out. Understood? I will explain in a more bigger picture and then I will delete it so that we could perform the program. I'll make it in little bit big, then you will understand. Let's make it here. So suppose that you have two nodes. Okay. So this is currently, this is your first. This is your first. Okay. And which address you have kept it here? Which address you have kept it here? This is your first actually. And this address is what? Which address it's keeping? You can go like this, no? First up link. Okay. This is your current link as well. This is means this is your current as well, which you want to delete. This is your current as well, which you want to delete. So since this was your first, this is your first. So that's how you wrote current equal to first. Okay. This first line. Then you are writing what you have to do actually. Now this second element, a second node should become the first. Since you have to delete this current node. So this, what will you do? First equal to first link. The moment you will write first equal to first link, then this will become first or not? The moment you wrote first equal to first link, so this became first. Now here what you have to do? Put it null at this place. The moment you will put it null, this will be cutted down or not? This node will be cutted down. So the moment this node is cutted down, so now in your list only this is the node left. Means you deleted the first position. Any confusion? Okay. So I think for writing the program I will have to delete it. So I will delete these things. But hopefully you understood what we are writing and what we are doing it here. And why we are writing. Now I'll just finish this thing in fast manner. Otherwise, we will not be able to finish it today. So this is done. Current equal to current link equal to null, and then you can printf deleted element is current data. You can write printf element age %d slash n current data. Okay, and then what you will have to do? Free current. Huh? This noted down? Then you will write to make that space empty, free. Now else. Now two conditions I am going to write directly. For in between means you will be checking the positions, and at last. So else we had written similarly in the insertion as well. Next equal to else, next equal to first, and now check the position. So while C is less than position, what you will have to do? Just note it down in fast manner. C less than position. So what will you do? Current equal to next, and next equal to next link. How we are going next equal to next link I had explained already in the insertion part. Next equal to next link and C++, and then you will write current link equal to next link, next link equal to null, for the last position. If you want to delete, so you will write directly next link equal to null, and if next equal to null means you have only 5 position and somebody has entered 7, means there is no next. This everybody is noted down. Now this next equal to null means invalid position. So if next equal to null, then printf, what will you write? Invalid position, else printf with a starting bracket printf slash n deleted element is %d slash n next data, and then free next, and then how many bracket you have to close? 3 bracket you have to close, which you had already started. Okay. Now, so insert delete done. Now we will be writing the display function and then main function. Okay. How much time is left? Still we have 15-20 minutes. We have 15 minutes now. Yeah, so in 15 minutes we will be able to finish it. Yes, so deleted item done. Now we'll write for the display. So which function you will use? Void display. Just write current equal to first, and while current not equal to null, while current not equal to null, printf less than %d current data. Means you will keep printing the current data, and current will keep moving to current link, means next link. Okay? You printed current, then go next, print that data, go next, print that data. So how will you move? With current link. Sorry? Yes, here it should be current equal to current link. Yes. So now this noted down. Now we'll write the final main function, and what will we do? We'll use some switch case so that you should know whether you want to insert, delete, and all those things. So we'll give the menu option. So let's write now final main function, and that will write in which color? Let's write in this. Void main in ch we are just giving a choice, CLR, SCR, printf, you are doing actually singly linked list, singly linked list. So do what you have to do. Give the choice first. Give the choice first. Huh? So you know that we can directly write with the printf. Printf. So which choice we will be giving? /n/n. Suppose that one we are doing for create. Means firstly you will have to create it. Okay. Second choice, second dot for delete. Okay. Or insert. Firstly we will have to give for insert, no? So anyway you can write delete as well, there is no problem, but let's go sequence wise. Insert, then third you give delete, and then /n, 4 you give for 4 dot exit. Display will come. Whether you are creating, you will have to display. Whether you are inserting, you will have to display. Whether you are deleting, you will have to display. Okay. So fourth one, let's write exit. And then you take the choice from the user. Printf enter your choice. Okay, enter your choice, and then you will have to use scanf for taking the choice. So scanf %d and %ch, because ch we have defined, and then use switch case. Ch, okay, case 1. So in case 1, what you have to do? Call create function and call display function. You'll have to call create function and you will have to call display function, and then what will you write? Break. Then let's go for case 2. Case 2, what option you gave? Case 2, which function you will call? Insert and then display and then break. Okay, then we will go for case 3. So in case 3, which all functions you are going to call? Delete, display, sorry, it's okay, whatever you want you can make it. So no, this DELET is not the keyword. This is the user defined function name. You can write your name. This could be reason. Okay, but these functions you can define by your choice. Okay, don't be confused in these. Then break you will have to call it now. Display and then break. Then go for case 4. Just write exit 0. And by default, what will be the printed? Means you are not entering 1, you are not entering 2, you are not entering 3, you are not entering 4. You are entering 5 or 6. So you can put in default invalid choice. It will work without that. That depends upon the type of compiler which you are using. Okay. Many times, whenever you are using online compiler, I have seen even you don't need conio.h. Even you don't need many times conio.h. So you can use that header file, there is no problem. Okay. Whatever is the required header file, whatever the required header file is there, you can use for all these. Invalid choice, and then you will close this. You just use here. Now do you had started, so you will use while 1 means while condition is true, and then close the final bracket. Hopefully this should work in your lab as well. Now what should you do? You should write this program. If there is anything, comma, inverted comma, bracket and all those things, these things you should cross check. Okay, while writing the program, all the errors you should remove. There should not be any error, but if there is any error because of commas, inverted comma and all those things, you have to do it by yourself. Okay, and concept hopefully you understood. Which are the conditions, how we use, which type of, how we write the code, like current, arrow next and all those things. In delete, which could be the conditions, which all the positions you can delete, how will you write the code, in insert, how will you write the code and all those things. Okay. So this is all about the linked list. Now, what should you do